Okay, let's do the same thing in 3 dimensions. Except now we're going to calculate. We're going to have a cube. Okay, and we're going to divide everything in half just like we did before on the cube. How many smaller cubes do we get this time? Can you tell me?
8 cubes.
8. Again, if each side has side length 1, each side of the cube has side length 2, each of these small cubes have side length 1, and I can put spheres in them. What's the radius of those spheres?
It's going to be half.
A half. Alright, and then somewhere in the middle here I have the central sphere, if you looked through, that would be tangent to all 8 of the spheres.
Alright.
Okay, and we want to try to find the radius of that. So what do you think that's going to be? What do you think we're going to have to do?
Well, we could try to do either the square method, or we could try to do what we did before. We could try to find the diagonal.
Okay, how long do you think the diagonal is?
So I think it's going to...
In a 1 by 1 by 1 cube. Going from one corner all the way to the opposite corner across the middle.
We know that that distance here, this is going to be root 2.
Uh-huh.
I think that's across, that's 2 root 3.
Well, we're going to end up with a triangle that
So
goes...
it's going to be 1.
It's going to be 1 high, root 2 across.
And then
Like that.
it's going to be, so 1 root 2, it's going to be root 3.
Root 3.
So just 1 root 3.
Yeah, so across the whole thing, from one corner to the opposite corner of one of these small cubes is root 3.
So that's going to be 2 root 3 across all the way.
It's going to be 2 root 3, right, if you go from there, one corner to the opposite corner.
So, then we...
And how many radiuses do we have
So we
of our small sphere?
We have 1. I think we still have 4. The 4.
4, okay. So we have, what's our equation going to be? To be equal to 2 root 3.
So 2 root, so
4r plus
2.
Plus 2 equals 2 root 3.
So 2r plus 1 is 2 root 3. And root 3.
2r equals root 3 minus 1.
So root 3 minus 1 over 2.
Alright. Pretty interesting, huh?
Yeah.
What do you think the answer is going to be for that radius in 4 dimensions?
Root 4 minus 1 over
minus
2.
1 over 2.
Okay.
Or 1/2.
So what's what is interesting in 4 dimensions?
It's actually an integer radius.
What else is interesting in 4 dimensions? About that in that central sphere.
Well, it's touching
Touching.
all, however many there are.
How many are there?
I think there's, so it'll be 16 of them, I think.
Okay. And when you say it's touching all of them, what do you mean by them?
All of the spheres.
Which spheres?
All 16 of the spheres. The spheres that you're putting inside these quadrants that you're chopping the thing into.
Right.
So it is tangent to all of those spheres.
Yep. Anything else special? What's the radius of the central sphere?
1/2.
4 dimensions.
Oh, it's half. The radius is half of the other spheres.
What's the radius of the other spheres?
1.
Not quite. What's the radius of the other spheres?
Or 1/2. It's
Or
1/2. Diameter is 1/2. Oh, diameter is 1.
So the radius is, this is 1 from here to here.
So that's a half.
It's a half. So what's interesting in 4 dimensions?
This middle sphere is actually equal to the other 16.
Yeah. Alright, let's keep going.